Now I want to talk to you teachers, both about the pedagogy of this problem and about the content, the mathematical content of it. So first, the pedagogy. Why is this problem such a joyous pedagogic experience for you? You will find that with a pretty high probability, you'll be able to, in the middle of this class, just relax. You'll be able to kick up your feet if you wanted to, and that's because what's going to happen is that there's going to be one group of kids who form naturally, who just love designing the puzzles, like designing those loops. And then there's another group of kids who just love trying to solve those puzzles that are created. And so you get this very natural cycle that forms that is extremely engaging for the kids. So that's why it's a pedagogically very interesting experience. And that's true for a lot of beautiful puzzles. You have extremely high engagement. You've got engagement for those top tier kids because they're dealing with puzzle exploration. They're trying to understand how to solve the puzzle. And then for those bottom kids, they're still doing skill acquisition. So let's now look at those skills that the lower kids are developing. So if we look at a grade 4 classroom, we'll look at grade 4 and then we'll look at grade 10. So for a grade 4 classroom, you can imagine that the kids are capable of drawing squares like this. They can go like this. These are squares that are orthogonal to the graph paper. Of course, grade 4 kids are capable of doing that. The reason that I can't take this problem down to grade 2 classroom is because grade 2 students are certainly not capable of consistently coming up with squares like this, where I have an algorithm, 1, 2, 3, 4, let's do 4, 2. So 4, 2, okay, so this is the next one, 4, 2, this will be my next point, 4, 2, this will be my next point, and 4, 2. So they're not capable of coming up with this kind of square. Not all the kids, at least, in a grade 2 classroom. So that's why this problem has a bound at about grade 4. Okay, so it's these squares that you need to be able to create in this puzzle. You need to be able to create these, and these ones they take a little bit of work for the kids to understand how to create these at about a grade 4 level. They're capable of it, but it takes a little bit of work. Okay, so at a grade 10 level, how is this curricular? Well, of course, at a grade 10 level, kids start to think about slopes, and you can imagine that it's kind of important for a grade 10 student to realize that this line has got a slope that is perpendicular to this line. And of course, that's very important in making squares. Hope you enjoy this. And the one thing that you need to be careful about in this problem is don't allow the kids to have to create enormous loops, because what's going to happen is that the kids create these enormous loops and it takes the other kids 20 minutes to solve. So that's not fun. So you need to absolutely say at the start of the class, you might say, okay, only create loops that are on a 5 by 5 square grid of dots, and then maybe you can increase that to a 6 by 6 or 7 by 7. So just don't let them go crazy with the size of puzzles that they create. Enjoy, and I will see you next week with a solution to the problem where, given a loop, find such a loop so that I can only find one square. Not 2, not more, just one square. And next week I will show you, I think I've got 2 solutions right now for that. But maybe by next week I'll have more. Take care. Talk to you later. Bye-bye.